This is the case of de-transposition of great arteries. In this parasternal long axis view, what you say, the structure first, this is left atrium. So this is left ventricle, this is right ventricle. From right ventricle, this is aorta. From left ventricle, this is pulmonary artery. So this is pulmonary artery, PA for pulmonary artery. What we bring here. This is pulmonary artery, this is aorta. This is right ventricle. This is left atrium, or this portion is left ventricle. Why we call it de-transposition? Because left atrium is connected to left ventricle and right atrium is connected to right ventricle. There is atrioventricular concordance, so normally related between atrium and ventricle. But when it comes to ventricle to great arteries, it is inverted. So discordance. So left ventricle is connected to pulmonary artery and right ventricle is connected to aorta. This structure is pulmonary artery because what we see, whenever aorta comes from left ventricle, it goes anteriorly. But in this case, you see the pulmonary artery is going posteriorly. At the same time, both pulmonary artery and aorta parallel in arrangement, especially in the beginning part. You see, this is like this and this is also like this. So ultimately, this is the de-transposition of great artery. This is transposition since the atrioventricular concordance. So this is de-transposition of great arteries. What I want to show in this image, this is aorta, this is aortic arch, this is arch, and this is descending aorta. This is descending aorta. So you can see the whole aorta coming out of right ventricle. That is the beauty of this image. This is parasternal long axis view, and we are getting the whole part of aorta in single view. This is aorta, this is ascending aorta, and this is arch, and this is descending aorta. So whole aorta is in the same view. That's the interesting part. Let us make it a moving image. That is the point. See the moving image. Now you clearly see this is descending aorta, this is arch, and this is aortic root, and this is ascending aorta. So this is right ventricle. From right ventricle aorta, this from left ventricle pulmonary artery. Why we call it pulmonary artery? In this case, you can see the whole aortic arch and descending aorta. So it is quite easy to see this aorta. But even whenever you find any great artery that is coming out of left ventricle and is going posteriorly, you see this is the plane. If in this plane, if you draw just like this, like horizontal plane, it is going posterior. This lower part is posterior. This image, this is posterior image. This is anterior image because probe is placed anteriorly on parasternal area. So this is most anterior part. This is most posterior part. So whenever parasternal long axis view will say you all about this, it is pulmonary artery because it is going posteriorly. Both have parallel arrangement. You can see the initial part of pulmonary artery is like this, and initial part of aorta is also like this. So both are parallel. See, this both is parallel. This like this. So this is the beautiful image because you can see the whole arch. That's why I have made this video to show you. This is parasternal long, very nice view. Moving to the next image. Same thing. This is pulmonary artery. This is aorta. So this is the case of de-transposition great arteries. You see this image. Same thing. This is pulmonary artery. This is aorta. This is left atrium. This is left ventricle. This is right ventricle. Right ventricle is most anterior structure from parasternal view. You can see the whole arch like this. You can see this is D-shaped left ventricle indicating a raised right ventricular systolic pressure. So systolic pressure within the right ventricle is quite raised. Right atrium, right ventricle dilated compared to left atrium, left ventricle. So in case of de-transposition, you will always find on this right atrium, right ventricle dilated. Here you can see this main pulmonary artery divided into right and left. You can see this is a pattern from an oval with flow from right atrium to left atrium, blue in color, indicating right to left. This is inferior vena cava. This is dilated compared to aorta. So this is inferior vena cava, dilated compared to aorta. This is parasternal long axis view. This is left atrium, left ventricle, and this is pulmonary artery. This is right ventricle. This is aorta. You can see that this blue flow is pulmonary artery. Thank you.